Okay, I will try to continue doing more fast our pre-next and rename and also the bounded information about of this formula. This formula it's I was working with the existential x, then the px, then the symbol universal x. This is implication. Then a q that has two arguments, which is x and y, and also we have here one this junction existence y, then q, and this q will have these two arguments, x and y. So this we have one conjunction here, and this conjunction will have the existential y, and q will have the y and the x, two arguments. Okay, so remember the first part is determine the what is the bounded and what is the free variables. So the first step is going to be as follow. I will put in red that this is bounded with this, and also we have this counter which is bounded with this x, and also this y is bounded with this. In this case y is bounded with this case, and this x is well, another thing, because we have here the parentheses. This is really important to note. But also I'm checking if we have some free variables. The free variables is here, and let me check it out if something is missing. Here this x, because it's inside of the parentheses, this most below to the first px and the existential x. So let's connect this with this part. So this is our bounded as well. So in fact we have two free variables, which is this one and this one. Also this is a free variable. So this is it. After we made this, we can separate the like if you are doing the tree. If you separate the tree, we get the next information like existential x, then px, implication all x, and in this q there are two arguments with x and y. Then this junction existence y. Remember that the counters do not need to have one parenthesis, but it's really important to put the parentheses in the variables, which is q, x and y. Also in the other side we left this implication, this conjunction, and we put the rest, which is existence y, q, y and x, and this is it. The tree of this is going to be as follow. We can put q, y and x, and this is going to be free variables. This is going to be bounded and one variable. And let's check this case. In this case we can separate this formula as follow. we can say that here is going to be px, this implication all x q x y, and then the disjunction for existence y x y without the parentheses. That's really important. Once we have this, we can separate to this part. Remember, here we separate this part, but now we can have the atomic formula. The atomic formula here is px, and the subset here is going to be the universal x xy, then the disjunction, I'm sorry, it's not existential, I'm sorry, I'm so sorry. And then this is the existential y, q, x, and y. This is going to be in parentheses. Now we need to divide this. Remember, this is not a universal. It's my mistake. It's just a disjunction, so we separate in two. So we have by one side the universal x, then x, y, that are two arguments, and in this side we have the existence y, q, x, y. And now let's make the atomic formula in this part. In the atomic formula we get this x, y, and here we have q, x, y as two arguments. So let's bond it and make free variables. Here are two free variables. That is for sure. But here we have one bonded and one free variables. This is the same case. We have here one bonded and one free variables. Since this is correct, this is going to be the same. Bonded and free. This is bonded and this is going to be free. This is going to be free as well. And here we have one bonded, free variable, bonded, and free variable. And here we have this bonded also connected with the last, which is this one, and y will have this connection. Also we have this x here and one free variable. That is the way to make our tree, our construction tree, and this is going to be the atomic formulas of this. So thank you for watching this video.